In this video, we're going to continue our discussion of vectors, and we're going to define kind of the standard position or the standard way of looking at vectors. So first of all, before we actually define that, let's just talk about what a vector is again. Let's just say I have a vector that looks something like this. So it goes from 1, 1 up to 2, 4. Now, a vector is just a quantity that has both a magnitude and a direction. So this vector is actually the same as if I had done, let's say, a vector over, let's maybe go down a couple, and then we'll come over here. So this would actually be the same vector as if I did this one. Goes over 1 and then up 3. Or if I put it over here. So every single one of these vectors is the same. Because they all have the same magnitude and they have the same direction. So what we're going to do now is define a vector in standard position. And so all this means is that its initial point is the origin. So if that's all that means, if we go back to this example up here, I'll redo the vector I just had. Let's say it was at 1, 1, and then we went up to 2, 4. So here's my initial vector. In standard position, that just means I'm going to move it over so that this point is there. And then I'm going to go over 1, up 3. And so this would be my vector in standard position. Okay. So now that we have our vectors in standard position, we're going to define a form for vectors so that it's easy just to write them down so that we all know what we're talking about. So we're going to define something called component form. And basically what component form is it's really just the coordinates of the terminal point when the vector is in standard position. So let's just go ahead and stick with the vector I just drew. It's at 1, 3. It ends at 1, 3. So that means that this vector, which I'll call v, is just the point 1, 3, except we put these sort of weird angly brackets around them. And so this would just be the vector 1, 3. Now this vector could be at a different location. It could be going from 1, 1 to 2, 4. This is still the vector 1, 3. And the way you can get that if it's not in standard position is you could say, well, the x component, that 1, you would get by taking the terminal point, which was 2, 4, and you'd say 2 minus 1, so terminal x value minus initial x value. And then for this one, you would just go 4 minus 1, terminal y value minus initial y value. So that tells me that for component form, we kind of have this formula. It would be, let's call it x2 minus x1, y2 minus y1, where the point x1, y1 is the initial point, and x2, y2 is the terminal point. But that's pretty easy in standard form because, like I said, you just take the coordinates of its final value. Now, usually the way we write this is we'll say it has some v1 and v2. So we say that v1 is the x component, and then v2 we would call the y component of the vector. And we'll be using this sort of language to define a couple other things in the next video.